Quantitative analysis measures the amount of product produced in a chemical reaction. So we're going to be looking at how much mass of a product we can actually produce. Limiting reagent. Reagent is just another term for substance. Your limiting reagent is the reactant completely consumed in the reaction. Because it limits the amount of product. Limits the amount of product. Excess reagent means it's the reactant that has some left over, right? It's in excess. So your excess reagent is the reactant that is left over after the reaction. And it's important to know which one is an excess. You don't want it to be the most expensive reagent, because then you're wasting money. So your excess reagent, there's some left over. And you always want to make sure you have one of them in excess to ensure that the other substance gets used all up. The first step, make sure you've got a balanced chemical equation. Now, we know we've got 4 moles of propane. 4 moles of propane. So we need to figure out how many moles of oxygen we would need just from a regular standpoint. So to get that, mole ratio. Convert moles of propane to moles of oxygen, which is the only place you use your coefficients from your balanced chemical equation. So 4 times 5 divided by 1 is 20 moles. I would need 20 moles. But to ensure I have 10% extra, you can do one of 2 things. You can calculate what 10% is and add it, or multiply it by 110%. Either one will give you your answer. One takes 2 steps, one takes 1. So I can do 10% and add it so that's 22 moles of oxygen, or 20 moles times 110%. What's the first thing you need to do? Balance it.
Yes.
All right. So now it says we've got a half a gram of sodium. What mass of chlorine should be used in excess? If you see the word in excess, you have to calculate the extra 10%. If it doesn't, you're just going to calculate it like normal. So a question will specifically ask you for excess amounts if you have to multiply it by your extra 10%. So we're going from sodium to chlorine. So how are we going to get there? What do we have to use? Stoic. Yeah, we're going to use our friend stoic. Or in other words, mole ratios. If we're going to use mole ratios, that means we need moles. So I'm going to show you two ways with formulas and then with dimensional analysis. So if you are going to do formulas, we need molar masses. But we need to know how much chlorine we need. That should be a question mark, not a P. All right. We need to find the mass of chlorine. So we have information about sodium, so we're going to find the moles of sodium first. So this is 0.021748. Okay, so we know the moles of sodium. We need to find the moles of chlorine. So we're going to multiply it by the mole ratio. There's 1 mole of chlorine used for every 2 moles of sodium used. Sodium's on the bottom so that it cancels. So we have 0.010874 moles of chlorine. We want the mass of chlorine. So we take the moles and we times it by the molar mass. So 0.010874 times 70.90. Anybody tell me what that is? If we want to know the mass of chlorine, we're going to start with the molar mass of chlorine because it's got grams of Cl2 where we want it. We want to get rid of moles of Cl2 because it's on the bottom, so I need to use something with moles of chlorine, but the only thing I have left is my mole ratio. So I want to get rid of moles of sodium, so I need moles of sodium for something, and I have that in my molar mass. Now I've got to get rid of sodium, grams of sodium, so I'm going to multiply it by 0.5. So now, the only unit I have is grams of chlorine, which is what we want, but it wants excess, so I have to still multiply by one more thing, and that's times 1.10. So everything's on the same line. Mine's a little bit down at the end, only because I've run out of room. 1.1, because that is 110%. I want 100% of my answer plus 10% more. Yeah, so if you're asked for an amount in excess, take your answer, multiply it by 1.1. Yeah. So in your calculator, you would have 70.90 times 0.5 times 1.1, divide by 2, divide by 22.99, and you should get the same answer.